Hello, Assalamualaikum and good morning. Today I'm going to explain about our lab work, which is star and delta motor control. So in this lab, we are using the triple MCB for the main circuit, and then the two pole MCB and single pole one for our control circuit. Okay, so for control circuit, we have 1.5 mm cable which supply the single phase current to the three of our contactor, which is this is the main contactor, delta contactor and star contactor. We also got a timer. This is the Omron H3CR timer, and then we're also using a TOR. And then we also got one start button and stop button, and two indicator light, which is red for trip and green for running motor. Okay, so for the control circuit first, the supply will come from here, the two pole MCB, and then it will go up to the single pole MCB, and then from the single pole MCB we directly go to the TOR. So for TOR we got the incoming TOR, which is 95, and then we will look to 97. So from TOR we got two outgoing, which is 96 and 98. So our 96 is normally closed and our 98 is normally open. So the normally open, if the TOR is straight, it will light up this red indicator light. So for the normally close, we got from 96, we will go to the stop button first, which is the stop button is normally close contact. Okay, so from the stop button, it will connect to the start button command. So from start button command, we need to put a latching to the main contactor to connection number 43. So outgoing from the start button, which is normally open, we also need a latching to the contactor to point number 44. So from outgoing, we took from the 44 to the A contact from the main circuit, and then the B contact we go to the neutral. Okay, then we also loop from A contact to the timer, point number 7. So outgoing from the timer is point number 2. Then we go to the neutral. Okay, and then we also loop the same point to a common contact on the timer, which is point number 8. We look to the point number 8, and then this timer also got normally close and normally open contact, which is normally close is point number 5, and then normally open point number 6. So from the point number 6, it will go to the interlock mechanism on the delta contactor, but this is the normally close contact. So the normally close contact is point number 31 for this delta, and then it will, from the point number 32, it will go to the A point on star connection, from star contactor. Okay, and then for this timer, point number 6, we go to the point number 5, we go to the delta contactor, but it will be normally open. This is for latching, because this timer we only triggered once, and we need this contactor latching to hold the instruction and make the current flow. Then from the outgoing of our latching, we connect to the star contactor, but the normally close contact. This is for interlock mechanism also. Then it will be to point number 31. Point number 31, and then going from point number 31, it will go to the light. It will go to the our indicator lamp green, and to A delta contactor. And then we got all the neutral to loop and meet at the same point. So that's all for control circuit. Okay, now I will talk about our star delta main circuit. So our supply will come out from the 3-pole MCB, and it will outgoing to our main circuit contactor. So after that, it will go outgoing to our TOR. Next, it will come outgoing our TOR will outgoing to our motor. So for the outgoing of our motor, will come out to our delta contactor. So from the delta from the motor, it will go for W2, will go for U, and V will come to V, and U will go to W. And with that, so after that, our main contactor will loop to our delta contactor. So but it will be a bit different, because our R will go to our S, while S will go to the R, and lastly our T will go to same T. So next, our star. So our main delta contactor will go from U to W, while our V delta go to V star, and lastly W delta will go to U delta. So and our RST in outgoing index is loop. That's all for me. Okay, now I will talk about our network, how it works. So now we will start our supply. So first we will start from our MCB 2 pole, 1 pole, and lastly is 3 pole. So next we will push on our start button. So we will energize our main circuit and start. For after 5 seconds, it will change to delta. So next we will push the stop button. Okay, now I want to show how to take reading from our working circuit. So the first reading we will be taking line voltage from incoming power supply. To take the reading of voltage, we need to set to the voltage AC, because we are using AC current, and then set to the voltage, and then this is the incoming power supply. So we will turn on the circuit and take the reading. So we have 2 probe, 1 probe on the red and 1 probe from the white. This is line voltage. We can get 417 volt. And then I will show you how to take the line voltage for incoming motor. So this is our motor incoming. So same we just put one on the U1 and one from the V1. So we get 417 also. Then we can take reading for phase voltage. So for the phase voltage is one probe on our line and one probe on the neutral. So we can get this is the phase voltage at power supply. So one probe at the red and one probe at neutral. So here we got 237 volt. Then we also can take the current reading from our working circuit. So to take the current reading, we need to set to the current and AC. So this is a clamp meter, so we just need to clamp a wire that we want to check the current flowing. So if we want to take the current from red, which is this is U1, so we just clamp it here and we can see the reading 2.92 ampere. So we also have a feature which is an inrush current. So to take inrush current, we just push this inrush and hold it. Then it's here inrush. So we just clamp it where our line we want to take, and then we just start the circuit. So here we can get it is 15.65 amp, which is so high. The inrush current happen because when our motor is static and it will start to turning on, it will consume a lot of current to make it rotate. So that is our inrush current. So that's all our reading that we can take.